The Wheeling-Pittsburgh Steel Galvanizing Plant, located in Martins Ferry, Ohio, is one of the largest producers of galvanized raw steel in the country. Each year, nearly 700,000 tons of coiled steel passes through the galvanizing process.
Welcome to one of the largest and finest galvanizing plants in the world. This pre-tempered Cook-Nordeman process was invented at the Martins Ferry plant. During this video, you will meet several of our employees who will describe in detail this unique corrosion-resistant process.
Galvanizing is the process of adding a zinc coating to raw steel in an effort to control oxidation and rust. This is done by immersing the steel into a zinc bath under controlled conditions so that the coating remains on the metal's surface for years. This application of zinc to the metal extends the life by some 5 or 10 years beyond a painted product on the same metal surface. Galvanized products find their way into every household. Washers and dryers, VCRs, and even parts of the television set contain galvanized steel products. One of the largest users of galvanized steel is the automobile industry. Galvanized steel is used extensively in underbody components to extend the car's service life. The Martins Ferry plant houses 3 continuous coating lines which process steel coils of various gauges and widths. The lines are identified by the largest width of steel that they are able to process. Thus we have the 36-inch, 48-inch, and the 60-inch lines. All perform the same basic galvanizing process. Production of galvanized steel began in 1907 at this facility and has continued through today. The 60-inch line has a rated production capacity of 35,000 tons per month. That is roughly equivalent to all of the steel necessary to construct a 2,000-passenger ocean-going cruise ship every 3 months. The keys to profitable, cost-efficient production of galvanized steel here at this plant are quality control, teamwork, and efficiency. As you will see, very little time or effort is wasted. From unloading the trucks to moving the coils into their proper place, from the entry end of the line to the signature stenciling and reloading at the other, the entire process is continuous and working in harmony with the computers and the crews on the line. From start to finish, the galvanizing procedure for a single coil takes an average of 17 minutes to complete. The time varies according to the thickness of the steel. We will follow the trail of the racing ribbon of steel as it passes through 13 separate areas, from the entry section through the process section, and finally to the delivery section. Our focus will be on the 60-inch line, but each step, with some modifications, is the same as is taking place on the other 2 smaller lines. Measuring 1,023 feet in length from the entry section to the line's end, the moving coil is manipulated, trimmed, coated, and cooled without ever stopping. Thus we have the term continuous galvanizing line. As we follow the progress of the coil, it is well to remember that not only are human eyes and hands at work, but also highly sophisticated computer and X-ray technologies are being employed to monitor processing sections. It assures that every finished product meets the high standards expected of this plant by our customers. Quality, value, and timely delivery are the hallmarks of this operation. As the coils are offloaded from the flatbed trucks, they are carefully placed in the coil storage area, awaiting their turn at the coating process. Each coil, depending on the gauge or thickness, weighs approximately 16 tons and is roughly 6,000 feet in length. Unusual care is taken to prevent any damage to the coil, and especially the edges. At the entry section of the line, placing the coil onto the uncoiler sets the operation into motion. Secured in place by the expansion of the mandrel against the inside diameter of the coil, the front end is fed into the flatness. This prepares the roll for cropping the front end back to clean steel in preparation for joining to the previous coil. As the coil in process reaches its end, the new steel coil is readied for its journey. As the drama of the line begins to unfold, We will skip ahead for a moment to the process section where a triple horizontal looping car holding 900 feet of steel awaits. It is essential to understand the looping process in order to understand the operation of the entire line. We have provided this model to show exactly how the operation works in a way that is easy to understand. We have substituted cloth ribbon to represent the steel coil. The red ribbon slowly moves through the machine, looping itself around each of the rollers. This bay can accommodate 900 feet of moving steel. Take special notice that the incoming wheel and the take-up reel are moving at the same speed. In a moment, we will stop the reel on the left to simulate the need for another coil to be added back at the entry section. When the entry section above is halted, the process section is allowed to continue because of the underground looping. Notice the rollers holding the stored steel begin to move from right to left, releasing the material back to the line. Even though the reel on the left is stopped, the line continues to function. At the actual looping pit, the storage area will yield its material in less than 3 minutes. During that time, the entry section crew prepares the automatic welder to fasten the new coil to the preceding one. Now notice that as the rollers near the left side of the storage bin, the crew releases the new coil into the system, and both reels begin to turn. The new steel is represented by the yellow ribbon. As it passes into the looping pit, the rollers again move back into position, storing another 900 feet of steel strip until the next welding cycle. Using this horizontal mechanical method, the 60-inch line never stops. In a similar fashion, on the 48-inch line, a vertical method of looping is used.
You've just seen an illustration of a horizontal storage loop. The other method of storing strip is referred to as a vertical accumulator. A vertical accumulator consists of a fixed set of rolls at the top and a traveling car with multiple sets of rolls at the bottom.
The car pays off strips as it rises and accumulates strips as it lowers. It is similar in operation to a basic passenger elevator that shortens the cable to rise and lengthens the cable to lower the car. Our vertical accumulator on the 48-inch line contains sets of 5 rolls at the top fixed portion of the accumulator and the traveling car operation. This configuration allows for 10 strands of storage at a maximum depth of 70 feet to provide 700 feet of stored strip, permitting up to 2 minutes of line running time while the entry section performs the welding operation. Now that we have described the continuous galvanizing line and the looping car process, we return to the entry section to view up close how the new coils are released into the process section. This is achieved by welding 2 strips. First, we see the end of the previous strip and the beginning of the next strip, prepared for welding. Then the welder positions the coils' laps in place for the welding machine to join them together as a continuous strip. The machine sears the 2 laps together. When the weld is completed, the changeover has been made, and the new steel coil will start on a journey that will bond another metal, zinc, to the surface of the steel. Once moving, the line goes to the final entry section area where the steel is trimmed. Here, side trimmers shear off unwanted material to meet the customer's width specifications. The scrap material is moved under the line to a scrap baler that rolls the strips into bundles. It is then removed from the scrap pit and saved for recycling. The extensive recycling programs at Wheeling-Pittsburgh steel plants are modeled after the best in the United States. The company participates in community reclamation projects at each of its facilities. Next on the line, the steel ribbon passes through a tension bridle to assure its flatness as it enters the looping pit to begin the process section. Once through the looping car area, the strip now begins the first steps necessary to become galvanized steel. It passes through a series of acid and alkali dip tanks, removing rust, surface deposits, and residue oil, as well as an electrolytic cleaning tank, further cleaning the strip, and multiple water spray rinses to remove acid and alkali. Once completely cleansed, a fluxing solution will be added to the strip on its way to the galvanizing pot. This preparation is all part of a unique galvanizing system invented at the Martins Ferry plant, known as the Cook-Nordeman process.
I would like to take a moment to compare the Cook-Nordeman hot dip coating used at our plant with several of our competitors' Zinzimer process. Our pre-tempered process is a cold zinc coating process cleaned with alkali and acid utilizing a zinc ammonium chloride flux dried on the strip. The strip is then heated to 500 degrees Fahrenheit and dipped into a 860 degree Fahrenheit zinc solution, which is air wiped to a predetermined coating thickness. Our competition uses the Zinzimer process, which tempers inline by the continuous anneal method, plunging the hot strip into the zinc bath and air wiping to a predetermined coating thickness. Our strip emerging from the bath will freeze quicker as the strip enters the bath cold. The Zinzimer enters the bath hotter than the desired temperature of the bath. We heat up our bath, they have to cool down. This allows our system the advantage of less iron-zinc alloy layer on the surface of the steel, time and temperature being the criteria for forming the less desirable alloy surface. Less iron alloy layer means better formability. The Cook-Nordeman advantages are speed because of no annealing restriction, softer lock-forming quality, easily produced drawing quality steel, and higher strength grade E. Why is the Cook-Nordeman softer than the Zinzimer? The Zinzimer continuous anneals in line, while the Cook-Nordeman uses more portable anneal previous to the line. The portable has the greater ability to make steel softer. Why is softer better? Because it's easier to form or draw. Remember our brand name, SofTite.
The zinc chloride and oxide compounds formed by the action of the fluxing agent being burned off at the entry of the strip to the pot must be removed from the zinc bath to assure the strip surface suffers no coating voids, known as uncoated spots. These byproducts are referred to as top skimmings.
We generate a lot of top skimming when the strip enters the pot that have to be removed. It is my job to remove the skimmings so that it don't have coating problems. It is necessary that I don't take zinc out with the skimming. I am also responsible for putting zinc to the pre-melt pot to make up for the zinc being removed from the pot on the strip.
On the exit side of the galvanizing pot, the strip passes through a set of air knives to remove excess zinc from the surface and to leave only the zinc coating thickness ordered by the customer. Coating weights vary from 0.4 to 2 ounces per square foot. The air knives accomplish this task through a combination of distance from the strip and pressure on the strip, which forms a damming or wiping effect, which permits only the required amount of zinc to flow past the barrier created by the air knives. The closer the air knife to the strip and the higher the pressure through the air knife, the lighter the zinc coating. An increase in the distance from the strip surface and lower pressure against the surface provide heavier zinc coatings.
My job as operator is to provide the customer with the coating that he has ordered and to maintain a quality of coating that he needs for his product. Basically, I set a line speed that maintains the pot temperature at 860 degrees Fahrenheit. I then move the knife distance and the air pressure to get the coating. I instruct the pot attendant to the amount of brightener to add to the bath to maintain the proper chemistry in the bath for his product. During the course of the run, I must pay attention to the strip and the controls to be prepared to make any adjustments that are necessary. In the event of a safety hazard, I am capable of stopping the line immediately from here in the pulpit.
Also a priority to Wheeling-Pittsburgh Steel is the relationship between the hot dip pots and the environment. That is why measures have been taken to assure zinc and flux fumes are cleaned before being permitted to enter the atmosphere.
At Wheeling-Pittsburgh Steel, the environment is a major consideration in setting operating procedures. We must meet state and federal regulations on air emissions to keep this plant and its people producing galvanized steel for many more years.
The installation of a new baghouse is further proof of this commitment. This baghouse will have a 4-module section for cleaning zinc and flux fumes from the hot dip pots. Each galvanized line will have its own individual module, with the 4th as an inline spare capable of serving any of the 3 lines if a problem would occur on any unit. Continuous automatic monitoring of critical operating parameters will point out system problems before they affect the efficiency of the unit.
This enables the continuous operation of the plant without sacrificing the quality of air emitted to the atmosphere.
As the steel strip continues through the process section of the 60-inch line, it is first cooled, then run through an impressive array of innovative procedures and quality control checks to ensure customer satisfaction.
We at Wheeling-Pittsburgh Steel place a high emphasis on quality. We all are aware of the importance of customer satisfaction to our future. We must ensure that our product conforms to customer specifications. Everyone is involved. Recent and future equipment upgrades are all geared towards producing a world-class product. From the recent installation of the new APC coating control gauges, DMC thickness gauges, Trion electrostatic oiler, and the air knives of the galvanizing lines, to the modernization of our 2-high temper mill, complete with hydraulics, extension control, and modern equipment, to the wooden cradles and felt pads on the receiving and shipping floors, to our joint labor management problem-solving teams.
One primary customer requirement is flatness. Wheeling-Pittsburgh is committed to meet our customer needs. Many of our current customers are converting over to automatic cutting and progressive blanking of steel. This requires a flat sheet. To achieve flatness standards and to exceed them, tension levelers are being installed on the 48-inch and the 60-inch galvanizing lines. This $8.3 million improvement will open new doors to customers due to the added capability to produce material to tighter flatness specifications.
A recent upgrade of the Martins Ferry plant testing laboratory included such items as a new computerized milling machine for precise sample preparation, a new state-of-the-art computerized horizontal Tinius-Olson tensile machine, digital readout Wilson-Rockwell hardness testers, and a new Olson cup tester, all geared toward reproducibility, repeatability, and accuracy in metallurgical testing, with customer satisfaction through conformance with specifications as our ultimate goal. One of the reasons we have been so successful and have produced galvanized steel for customers throughout the world. As sales increase, another key element in the efficient running of the Martins Ferry plant is our transportation fleet.
The primary duty of our fleet is to move the intra-company steel as quickly and economically as possible. The fleet routinely is required to move over 60,000 tons every month to our various locations in our lower Ohio Valley.
Our modern fleet is responsible for transporting material between Martins Ferry, Steubenville, Yorkville, and Beach Bottom. When necessary, this facility has shown that it can handle over 80,000 tons in a month. This is accomplished with approximately 37 drivers and support personnel. Another integral element of the production of galvanized steel at the Martins Ferry plant is the safety of those who produce it.
Wheeling-Pittsburgh Steel Corporation was among the first in industry to experiment with scientific safety for workmen in the early 1900s, becoming a forerunner in the development of an organized safety program.
Today, the emphasis is on safety training. All management and bargaining unit employees attend training sessions on various subjects, including lockout, tagout, hazard communications, and hearing conservation. The increased awareness becomes apparent in relation to the plant's low accident frequency rate. As recipients of such awards as Wheeling-Pittsburgh Steel's President's Safety Award, as well as from the National Safety Council and the Industrial Commission of Ohio Safety and Health Division's Achievement Award, Group Award, and Special Award, we have good reason to be proud of our outstanding safety achievements. As we have seen, the Martins Ferry plant strives for excellence in every aspect of the galvanizing process, from the continuous lines to the environment, from new technology to high safety standards. With so much effort that goes into this process, one might wonder the actual effect that galvanizing has on steel. One might ask, why do we galvanize steel? Rust is caused by various elements in the air itself, differing with each geographical location. Therefore, the working life of a steel product is being controlled by the environment. The three pieces of steel shown represent metal that is painted, unpainted, and galvanized. With exposure to identical elements for 3 years, it is easy to see the effects on our samples. You can notice the rust forming on both the unpainted and painted samples. None on the galvanized piece. After 2 more years, it is obvious to anyone as to why we galvanize steel products. The final steps to a finished product occur in the delivery section of the line. Strip dryers dry the passing steel from more acid and chemical dips on its way to the recoiling area. It is very important that the steel coil is dried thoroughly, as it will be rewound for storage and shipment. At this point, the symbol of worldwide quality, the Wheeling-Pittsburgh Steel corporate logo, is stamped on the face of the rewinding steel. Now proudly imprinted with the trade name SofTite and Wheeling-Pittsburgh Steel, the galvanized steel is recoiled and sent to the shipping field. The coils are transferred to either barge or truck departure points. Finished product does not stay in the plant very long. Customer orders are filled promptly and processed for shipment immediately. The Wheeling-Pittsburgh Steel galvanizing plant in Martins Ferry has achieved worldwide product identification and a history of customer satisfaction that assures continued reorders and new orders. Living up to the reputation that SofTite products handle better, form easier, and hold form better is a tribute to a team effort. In an ongoing process of improvement and product expansion, line modifications are routinely developed.
The Martins Ferry plant is expanding its product line. We've designed modifications on our 48-inch continuous galvanizing line to produce Galfan.
Galfan is a new generation zinc 5% aluminum mish metal alloy coating for steel. The unique characteristic of Galfan is the key combination of greatly improved formability and paintability with a much longer corrosion life. The major market area for Galfan will be the appliance and construction industries. Presently, there is only one major producer in the United States.
We believe the production of Galfan will not only increase employment, but temper any downswing in the market for our galvanized products.
We at Wheeling-Pittsburgh Steel's Martins Ferry plant are proud to be part of one of the largest steelmaking companies in the industry. We are large enough to be price and quality competitive in the international steelmaking arena. We pride ourselves on being able to handle very large orders and also small specialty orders. As our satisfied customers will attest, we provide fast turnaround and quick response to need. Our investment in this plant is an investment in our future. We plan to remain a major player on the global marketplace. We hope you have enjoyed this tour of the Martins Ferry galvanizing facility. As we all move into the 21st century, advancing technology is certain to improve upon how steel is made. It cannot, however, improve on the pride, dedication, and commitment of the thousands of talented people working together to make a quality product. We intend to continue to produce some of the finest steel products in the world. We are people who make steel for people just like you.